I work for Red Hat. I recently transferred from the Spice team to the graphics team. And I have been working for about the last 6 weeks on getting the X server to run without root writes, which is something long overdue, as the sheet says. So these are today's topics, which I plan to discuss, and hopefully we'll have some time for questions at the end. The first question is why? This is sort of a mandatory question. I hope no one really seriously asks why, but for those who do. The X server has traditionally always been root because back in the old days when we all had 486 machines, graphics were done from user space with user space mode setting, and we needed direct hardware access, and doing direct hardware access means you need to be root to make certain system calls like the IOPL call, which gives you IO permissions. But the X server is a quite large, complicated body of code, and having that run as root is security-wise not really something which we want. And with KMS, all hardware access is now done in user space, so we no longer really need the X server to run as root. So this, hopefully, for those who were wondering why would you want to do that, well, mostly for security reasons. But what do we need? We need access to dev input event and device nodes and dev DRI card device nodes, which are currently open only to root most of the time. We need to do a couple of VT ioctls for VT switching, so switching to text mode or switching between different X servers which are running. And we need to be able to log somewhere, and our current default log location is root only. So one of the dependencies is device access. Device access is typically restricted. For input nodes it's typically restricted because of things like eavesdropping. You don't want, if you have a multi-seat system or users logging in remotely, be able to listen to what someone else is typing on the keyboard. Just opening up the writes, we have a mechanism. It used to be ConsoleKit, now it's done through systemd lognd, where we tag devices in the UDEV database with a uaccess attribute, and then automatically the device nodes get opened up. The problem is for local users, so users who are present behind what we call a physical console, so something which is local to the machine. That's not enough. DRM set master, which is necessary for kernel mode setting, requires root writes. Having permission on the device node is not enough. It will still not allow you to make that call. And some sort of arbiter is necessary for input devices, because if you are doing fast user switching, so you're switching between users on one physical head, then you want to revoke input access to the X server, which is running on behalf of the user, which is stepping away from the machine, so that he won't be able to eavesdrop on other people's what they're typing. So these two reasons are why just using uaccess tricks is not enough. Luckily, the Wayland people have the same problem, and they have been thinking about a solution for this. This is I'm sort of building on top of things mostly done for Wayland here. They came up with a new API, a part of systemd lognd, because systemd lognd already does device management and seat management, etc. Which starts with the take control, which makes you a session controller, and then you can also take control of various devices which are attached to the head on which that session is the active session. So this is assuming we modify the X server to use this API and get file descriptors over dbus from systemd lognd. This is sort of a solved problem. So how does this look inside the X server? I have a couple of API and thus also ABI changes coming up for drivers, which involve something I call server managed file descriptors, because the X server will be managing the file descriptor for the device node instead of the device driver doing it on its own. A driver's pre-init for input or foo probe function for video. It's called foo because there are different probe functions for video cards. Method will be passed an open file descriptor by the X server if server managed FDs are active. This is all optional. People don't need to worry that this is going to become mandatory, at least not in the near future. We also need to still have the X server running on Solaris and whatnot. This is all optional. So it will get passed an open FD, and if it's a video driver, the FD will already be DRM master. A slightly trickier area is switching between VTs, right? You know, you have the X server running on VT1 or VT7 depending on your distro, and you can switch to a text console, or you can even run multiple X servers on different VTs. VT leave actually is pretty easy. because I chickened out. We keep using the VT process VT mode. That means that the VT, the virtual terminal in Linux terms, is put in a special mode where even if you use a hotkey combination to switch away, you won't get switched away immediately. Instead, the process gets a signal from the kernel. I want you to go away from this VT, and then the process, in this case the X server, has all the time to do all the cleanup it needs to do, safely shut down all the devices, save device state for the GPU and what's not, and then it can signal the kernel, okay, you can continue. We will keep using this in Xland because otherwise there's way too much code to audit to come to something which is safe for asynchronous switching. For server managed FDs, the server will do a DRN drop master for the video devices, and it will, for input devices, it will close them because they get revoked, and after that they're useless after a VT switch. But this will happen after the normal leave VT code has run, etc. So nothing much changes for the drivers here. On VT enter, the story is slightly more complicated, because we will get a signal from the kernel at the same time that systemd lognd gets a signal from the kernel that our VT is becoming active. Normally, in the old case, we used to just, as soon as we got the signal from the kernel on VT enter, we would start reinitializing the GPU and what's not, reopening input device nodes, etc. We cannot do that because they are being opened for us by systemd lognd in an asynchronous manner. So what we do is we wait for systemd lognd to give us dbus signals over which it passes new FDs for input devices, and it signals us it has retaken the master mode for video devices. We first wait for all the video device nodes to be back in master mode, to be resumed in systemd lognd terms. And if at that time we already get some file descriptors for input devices, we put those on a list. We remember that those need to be resumed later. Once we have all the video device nodes, we basically do the normal VT enter handling we were always doing. So again, from a driver point of view, there is not a whole lot changing. The driver should not call drop master itself on leave, it should not call set master itself on enter, but that's pretty much all the changes at the driver level. For input devices, if input devices arrive after we have done the VT enter handling, so they get resumed later, then we just re-enable them immediately, just like we re-enable them immediately on hotplug, if you plug in a mouse or whatever. So that concludes the part where the driver ABI changes are necessary, etc., and the problems with opening device nodes which we had. Then there's the problem with, we want to keep using VT process mode, so we need to be able to make a number of VT ioctls. Actually, this is allowed to do without root rights. If you are in the same session ID as the active session, as in the process management in the Linux kernel sessions, which is controlled by the TTI. But by default, the kernel puts, the X server puts itself in a new session ID. It detaches itself from its controlling TTI. So we need to stop doing that if we want to be able to run as non-root. Because you can only make these ioctls if you're either root or you are in the same session ID as the controlling TTI has. So this is, again, pretty simple. Logging is also not all that hard. We can simply no longer write to var log. Right? We cannot do that as a normal user. So there are two solutions, which will probably both get implemented, and then distributions can choose if they want to enable this, how they will use it. One is to log to a place under the user's home directory, which by default is the XDG data home directory, which is sort of the default standard for logging inside home directories. And the other one is to log directly to journald. Some people may ask, why not use syslog? Because syslog is an easier way to get to journald and may also be useful in other scenarios. The problem is that the syslog, a system call, is not safe to call from within a signal handler. And we do logging from within signal handlers, because input I/O is driven through signals inside the X server. And that's also the problem for this. Leonard has already been reviewing patches to make some journald system called signal safe. Now you know where those patches are coming from. So as I said before, we need to be able to the X server needs to have a controlling TTI. That means that the display manager needs to do slightly more work. Because so far display managers have been cutting a lot of corners and just trusting. They have not really been starting the X server in a valid user session. In the typical sense of PAM, etc. So in order to work with systemd login, these API to control a session, we need to be inside a proper user session. So display managers will need to be changed, things like GDM, KDM, LightDM, etc. They will need to start Xorg in a proper user session. So they will need to first set up a user session, set up the PAM session info for that session, make sure the controlling TTI is set up right, and then they can start Xorg inside it. This also means that display managers will need to start Xorg twice. Currently, a GDM starts Xorg just as root. Then it starts the login screen as a GDM user. And after that, it reuses the same Xorg server to start the user session. It will need to start Xorg twice now. Once to slow the login screen, and once that's done, it needs to tear it down and start it up again as a regular user. Some more work will be needed to maybe make that transition not be ugly. And optionally, the display managers may want to redirect the Xorg logs somewhere, assuming we're not just going to end up using the journal for those. This one I don't like. My favorite answer to this question, what to do about the user space mode setting drivers, because there are still a couple around, is just kill them. Kill them with fire. But I'm afraid that won't be an acceptable answer to some of our users. So we need to come up with something else. The first option is probably what I'll be doing somewhere in the next weeks. Add a set UID root Xorg wrapper, which is completely makes no sense. I'm killing Xorg running as root, and now I'm adding a set UID root wrapper. But it's probably the easiest way, and I can make it pretty safe. It can just check if there is a kernel mode setting capable card, and if there is one, it will just drop root writes immediately, 10, 20 lines of C code, which hopefully can be audited to be safe. Famous last words. And if there is no kernel mode setting card, then it will just fall back to the unsafe mode. This will probably be optional. So if for distros I can envision this coming in some sort of separate RPM package or DBM package, and users can remove it. Or maybe we won't even ship it by default. Further in the future, it would be interesting to use simple DRM. Simple DRM is something which David Herman did, who gave the presentation before. It's actually part of the stuff he did for Miracast. It's the user space driven frame buffer driver. In combination with UVESA FB frame buffer to actually use the VESA BIOS to set up a dump frame buffer and then throw simple DRM on top to make it KMS capable, and use that as output on machines which don't have a card which is supported by our kernel mode setting driver. These are mostly IDs. I am very much open to discussion and suggestions here. So a demo. Well, you have been watching it. This is my Xorg log. Before I show that you have been watching it, there is one thing since the Intel guys are Jesse is in the room. It's saying this to me when I run as non-root. We need to look into that.
So another thing needs to be burned with fire is anything related to backlights.
Yeah, and it's actually a real error. It's not just saying this. I also lose the capability to control my brightness on my laptop screen. So.
What's the goal with backlight? Like, are you going to move it into the X server where it belongs and just drop the?
I have no idea. Hopefully Jesse will have some time to discuss this with me later.
Well, that's the API we use today. It's just a test backlight API. So that needs to get changed. Ownership needs to get changed in the session.
But you want to keep that, or do you want to move it into DRM? Sorry. Yeah, thank you.
I think we'll be sticking with this for a while. We have, yeah.
We are not going to change my file instances.
No.
So,
Absolutely wrong.
Why we use it for API?
No, we're not.
I suggest we just open up.
No option for that.
I mean, like the thing is, like we can do access control on device nodes, but never on stuff in /sys. But the backlight stuff is only in /sys and doesn't have a device node.
Okay,
so
we're
what's the?
responsible for adding this as API. So it's just what we use.
Yeah. I know, but right, but there's no option. You don't have to revoke nothing, so users can keep the crap open, and you cannot solve it in SysMS. It's not made for untrusted users to ever write it.
But how bad is it if we just open the brightness control to the world?
Well, maybe. I don't know. I'm just
Yeah.
telling from the perspective of SysMS. There's no option to open that ever up to untrusted users.
Well, another option would be for us to add it. We've got properties for this on the DRM side, so we could just have a brightness property and hide anything.
Like bypass it.
We're just discussing implementation options.
Yeah. I haven't thought about this yet because I only noticed this when I was preparing this demo. So.
So how do you handle backlights?
Wait for them.
I'm going to be running.
Sorry, one more question about the backlights. How are you going to handle backlights in DRM when the backlight device is different from the GPU? Like this MacBook has some separate chip that's not in any way, as far as you know, related to the GPU. To which DRM device do you link that?
The answer to that is I have no clue. As I said before, I noticed this like 30 minutes ago. I just thought this would be a good audience to mention it to and maybe get some ideas. But so to show this is really the demo. Over here you see my the second line. This is my X process, and it's running as user Hans. And basically what I've done is I have disabled graphical login. I've programmed it to run level 3, which is not true because it's using systemd and it no longer has run levels, but I've told it to only start up with text VCs, and then I do start X on the VC, and since at least the text mode login knows how to properly set up a user session, unlike GDM, I can just do start X and it just works. So, well, we were already sort of here anyways, but are there more questions?
Wow.
How too quick did I do it? Well, very much too quick.
Yeah,
How quick?
quick.
So it's not really a question, just something I wanted to mention. You keep the TTY ownership to the X server, as you said. In the long run, we hope to make X something that is actually forked off the user bus, which basically means it's detached from any TTY because it's a singleton that is shared by all sessions of the same user. So that means it will not have one TTY to be attached to, and it couldn't even attach to that. So there might be something to think about.
Yeah, that's a problem.
You know.
Maybe do something special for X in the user bus.
Yes, for a session management problem, you don't really need the X server to run under the same user ID than the session that is running under X. In the work that I did to implement privilege separation in X for OpenBSD, when we start the X server under XDM, it just run under an X11 user, and almost everything works. There is just a little problem with shared memory segments, but the new API that Keith committed a few weeks ago that allows to create shared memories and pass a file descriptor to it solves this problem too.
Yeah, I guess we could do something where we make the X server set UID again, but make it set UID to another user. I wonder though how useful that is, because any program capable of attacking the X server will very likely already be running inside the user session, so it already has the same rights as X. So why would it bother with attacking the X server?
It's just to solve the issues of not having to restart a X server between the login, the display manager, and the actual session. You can just choose an unprivileged UID and run under this.
And that's
UID.
not going to work with systemd login integration. Systemd login will want to see the X process as part of the session, otherwise it won't allow it to take control of the various devices. It won't allow it to open your mouse, it won't allow it to open your keyboard. Because the user who is on the active user for that seat is the only one who is allowed to open the keyboard and the mouse, etc. If you start thinking multi-head systems, etc., that just won't work, what you're suggesting. You need something smarter. Yeah, wait for the mic, please. Otherwise the video people become unhappy.
We don't have video streaming, but
We do.
we do?
Yes. Oh yeah.
Give me the link.
Okay.
If I got you right, it will be impossible to use this non-root X without systemd. So in such distributions like Debian, where we still do not have this, it will be unusable.
Yes, as said, I will keep things working in the old-fashioned for Solaris and whatever. This is all optional, but you will need systemd lognd. But distros will, even if you don't want to use systemd, you will need systemd lognd anyways. Everything is moving to systemd lognd. ConsoleKit is dead. No one is maintaining it. So you need to figure out something like just switch to systemd already. It's just better.
Just to quickly mention that lognd has been ported by the Ubuntu people to non-systemd. However, the take controls bits, like the device access control bits, are not included in that version because it's really old. And yeah, so good luck.
So, more questions?
Seems like that is your talk.
Yes.
20 minutes.
Yes.
You do know that you have to fill 2 slots now, right?
I can talk about all-winner devices or something, but
No, that's reserved for tomorrow. So.
I know. No, it was going faster than I expected. But
One more question here.
If you already started an X server for the GDM login, couldn't you keep that running and have, if another user wants to log in, just switch to that X server instead of tearing it down and starting a new one?
that is actually what we're doing today and what we want to get rid of, because the way systemd lognd works is that a certain user is seen as the owner of the active session on a head. And that one is the only one which is allowed to open things like the keyboard and the mouse. And even if although the process can keep the file descriptor open, a revoke ioctl will be done on those file descriptors by systemd lognd as soon as another session becomes the active session on that head. So the X server could keep running and it could keep the file descriptors open, but it can no longer do anything with the file descriptors, including reading from them to get input. So it just won't work as far as I know. Can we get the mic back to the front, please?
So this, of course, results in the next question, which is if you have the X server for GDM and then later on the X server for the actual session, how do you make sure that it doesn't flicker?
We have the same problem already when we go from the boot splash screen to X, or when we switch on X between multiple consoles. We will have the same problem with Wayland, because Wayland is following the same model, where you will have one Wayland for the login manager and a separate Wayland for... This is something which needs to be solved by the graphics people, maybe with some extra kernel API, and just have some way to get the current content on the screen. So the X server needs to be able to shut down without corrupting the screen, and then the new one needs to be able to get the old screen content and do a fade over or whatever. I know David Herman was thinking about it. I'm not sure, is he back in the room or is he still discussing?
That's a security problem. Like, I mean, if you can read out the screen of what's on for before
That's a good point. Then maybe we need to have the X server which is dying fade to black and have the other one pick it up from there. Or
So nobody from the graphics camp has thought about this yet?
I know they're thinking about
They're
it.
all in place.
Oh yeah,
It's already done.
Yeah, I mean, the old user space thing just needs to fade to black, and the last thing that has been displayed will stick around. So if you leak some stupid stuff like your password or banking details, yeah, that's your problem. But we keep everything around until the next server picks it up and can smoothly transition to whatever it wants to.
So something like the display manager, which knows that there will be no sensitive info on the screen, could even just keep the old content for a better transition.
But I mean, it used to switch back to text mode. So is this assuming that there is no text mode anymore, or is this restriction with switching back to text mode if there's nobody who wants graphics gone?
Ping pong.
If the last thing that kind of controls the last year-end device closes and everything dies, you forcefully switch back to the FBCon and your kernel under the assumption that just everything died, and you actually want to like log in through VT and see what happened. But as long as someone keeps open a DRM master node somewhere, we're not going to do that. So as long as your system login thing or another session keeps a DRM device open, and otherwise just call FBCon. The world is a better place without it.
So what's the status of your work right now? Is this something that could be sent upstream tomorrow, or what do you have left to do?
Not tomorrow. I have some review comments from Dave early on my first version of the patch set, so I need to rework some code. But in about a week, I should be able to send it upstream. Actually, a lot of the preparation patches are already upstream. I had to split some functions, etc. That's already all upstream. So yeah, this is definitely going in the next major release of the X server, so 1.16.
As you already have a X server for login, can't that one keep running and just spawn a new one for the user that logs in on a separate VT or whatever it's being called in the future? So
opening a separate VT requires root rights.
Yes, but that's a task for login day.
Yeah, yes, it is possible to keep the X server for the display manager running on, say, VT1 and put the user session on VT2, and then you could even just, when you choose the fast user switch option, it could even be just a switch to VT1 because GDM is already waiting there. That's an implementation detail of the display manager. Okay. It's even possible that one display manager chooses one model and another display manager chooses the other model.
That was mostly my question, yeah. Thank you.
At the reason of committing heresy here, did you think about if the binary driver can make this work?
Yes, actually, I've already been in contact with the companies behind the binary drivers, and for now it definitely won't work for AMD because AMD is still banging I/O from user space. For NVIDIA it looks slightly more promising, but they also have some work to do. For now they will probably just fall into the category which is handled with whatever solution I come up with for a user mode setting driver compatibility.
Well, off the record, as far as I'm concerned, the AMD driver can die in a fire. It's just the NVIDIA driver that still has some value.
Yes. But yeah, I am keeping an eye out for those drivers and trying to keep them to work. Somewhat. So, if there are no more questions, then I wish you a pleasant second lunch break, and thanks for your time.
So the next presentation has been cancelled, so you have an extra long one.
I didn't know that.
Yeah, the plane of the presenter got stuck in. So yeah.
Oh, that's too bad.
Little test. Hello.